Hello, and thanks for tuning in. Today we're going to be talking about sampling, which is an extremely important aspect of working on experiments. We've got to make sure that we get an adequate sample that's a very good representation of our population. So I'm going to demonstrate a number of techniques that are used for this using a deck of cards. Hope you enjoy. Our first form of sampling is simple random sampling. So I will pull out my deck of cards, and it's important to know that in order to do simple random sampling, you need to make sure you have the entire population represented. So I'm going to look and make sure that I have all of my cards for this particular suit. What's an example of when we might do this? Suppose that you are working with a wonderful data science class and you want to say, I'm going to put everybody's name in a hat. I'm going to reach in, I'm going to pick one of those names, and they're going to be granted an A on the final exam. So we want to make sure your name is represented in this random sample. So I've got all of my students' names conveniently numbered from ace to king, and somehow I'm going to randomly pick a sample. How am I going to do that? Well, if I was putting in a hat, I'd probably fold the names up. But instead, I'm going to just do some shuffling, throw them out, and randomly pick my sample. So here I've randomly picked a 2. Maybe I'm going to do the top 3. Got another. I drew the king, and then one more, a jack. That's simple random sampling. Our next sampling technique is systematic random sampling. So in order to do this, I'm going to just lay out all of my cards in order. I'm doing that. I'll tell you an example of when you might use this technique. Perhaps you are wanting to survey political viewpoints of patrons that are walking into the local grocery store, and instead of, it's a busy grocery store, you don't have time to survey every single one. So you might decide, well, I can only survey every 3rd patron that comes in. So you're going to pick an increment. That will be your N element. So you're going to pick every nth customer that comes in. For me, I will pick 3. Meaning I'm going to look at my list of cards. I'm going to go find the 3rd card. 1, 2, 3. I'm going to take that one. I will then go 1, 2, 3. I'll pick that one. 1, 2, 3. 1, 2, 3. It's going to be an effective means of sampling because it does, kind of ensure that you're going to get a good representation. There may be some kind of a odd scenario where there's a particular frequency that's introducing bias, but by and large, it's a pretty decent way of being able to narrow down the sample that you're working with. Next up, we have stratified sampling. In order to use stratified sampling, we are first going to find some sort of grouping, some kind of clustering perhaps. If you were surveying for favorite type of music, perhaps, you might want to divide this by age group, thinking that maybe children listen to different music than teenagers versus young adults versus senior citizens. So you can divide that specifically and come up with ages. So I'm going to do this by dividing mine into a clubs, a heart, a spades, and a diamond. So I have first done that. And then afterwards, I'm going to turn to simple random sampling and sample however many items I want from each strata. So if I want 2 from each, I would then take this one, shuffle it up randomly. We're going to pick 1 and 2. Let's just see how random this works out for me. For this one, I'm going to mix it up. I'm going to pick 1, and I'm going to pick 2. Same thing. Get those confused over there. Going to this one, I'm picking 1 and 2 at random. And then last one, going through, randomly picking a couple. So those are going to be my samples. Just out of curiosity, how did we do at randoms? I've got a pair of 9s. Hey, not too bad. Mixed it up pretty decent. So that's our stratified sampling technique. Let's move on to cluster sampling. Initially, this might sound a little bit like stratified in that you are identifying clusters, but this works out very good for scenarios where you're working on maybe geography and you are trying to narrow down what you're going to do. An example would be you're trying to find out the income level of people in a city, a large city, and it'd be too difficult to survey every single one of them. So instead, what you would do is perhaps cluster them into blocks, each block of the city. And from that, you will randomly decide how many blocks are we going to survey. So in my scenario here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 blocks. And I would decide I'm going to randomly pick 3. That's what I'm going to do. I'm randomly picking 1, 2, and 3. Those are the 3 that I'm going to do. Now, for cluster sampling, we are now going to survey or evaluate every item in that cluster. We have to be careful about this because this really has a potential to introduce bias. Let's just take a look at mine. As I did this, I ended up with a cluster where I picked ace, 2, and 8. I've treated ace as a 1, by the way. So I have an ace, 2, and an 8. Over here, I then have a 5, king, and a 5. A little bit off. But the third one, I have all face cards. So we have to be careful about that and be cognizant of the fact that we may be picking certain clusters that are well outside of our mean. So check that out, see what you think of it. Up next is convenient sampling, and this one couldn't be much easier to discuss. Here we need to find 3. We want to work with a sample size of 3, and if we look over at our board, we see we've got lots of different things, but convenience says, oh, these 3 are pretty close, so I'm just going to take these 3. How convenient it is. Who was available? It was easy to access, and that's what I'm going to use. Is it going to be the most reliable? Well, probably not. You may be frowned upon with your research if you're using convenient sampling. When we look at judgmental or purposeful sampling, we are thinking about experts. We think we are going to be able to reach out to people who are going to be the best representation of this. Maybe we don't want to survey Joe Schmo about nuclear fusion. We think it'd be better to reach out to scientists with actual degrees and such. So if we have our population over here and we are trying to find out I got to be careful about this one. The best place to vacation. Who are we going to reach out to this? Oh, we're going to reach out to the ladies. I know from my own personal experience, my wife knows best. She tells me she knows best. So I'm going to reach out and specifically grab hold of these experts for this purposeful examination. Quota sampling is a neat way to go about doing this also. In this scenario, we are kind of looking a bit like stratified sampling because you are going to break your population into some sort of a cluster, into some sort of a strata, but it is not random. You actually need to know some information about your population, including the proportions of your different groups. So for my scenario, I might want to put my scenario as face cards versus numerical cards. So when I do that, I can think, all right, the numbered cards go from ace to 10, so there are 10 of those. But our face cards are only jack, queen, and king. So there's only 3 of those. So I'd want to make sure that I had a proportion, that I was doing this proportionally. So I would go and separate all of those into the correct portions. I would set up, determine what ratio that I want to do it. And then from there, I'm not going to do actual random sampling. I might just do convenient sampling, where I'll just survey the first 2 people who walk in that happen to meet that qualification, or in my case, the top 2 face cards. And same thing for the numbered cards. I might pick the top 4 or 5, whatever the case may be that I've decided is the proper ratio for this. So it allows us to get a unique way of gathering all of our data and getting a good representation of that in a proper ratio. The last form I'd like to discuss is geometric propagation, or snowballing. In this scenario, we are going to find a particular a specific case that we're interested in working with. Our textbook does a great job of describing we are working with somebody that has a specific disease, maybe a pretty rare, unique disease. So we're going to find that person, in this case, 5. 5 is our card with a rare disease. And we don't know who else really to talk to. So snowball, 5, it says, hey, I've got a support group. I know other people who have this particular disease, so they are going to go out and find other people. Here's another 5. They're going to reach out. They're going to find another 5. And perhaps each of these is going to know other people, and it will do just like the name suggests. It's going to snowball, hopefully, to a good long list of data points for our sampling. Sampling is definitely a science, and there is an art to it. You may find out that when you're doing your research that you've started with one form and you're not pleased with it, so you change how you go about it. Hopefully you're going to do this early on and not halfway through your results section and have to throw everything out. A lot of times it depends on ensuring you have the proper amount of information. I happen to know when I was working with this that I'm missing a few of the spade cards. And so even though I said that we need to make sure that we have the entire set, I may have thought I had the entire set, but it turns out I didn't. These are all things that you'll deal with. It's also going to come into play as you calculate things like the sample size and your confidence level. So I hope you enjoyed this. Be sure to play around with it. Check out all of these different types of both random and non-random samples and see what kind of great data you can come up with for your data science project.